Okay, this is going to be an example of a second class lever, and a wheelbarrow is what this is supposed to be. We have the load right here. We have the fulcrum at the end where the wheel is, and the way that a second class lever works is the load is going to be on the same lever arm, on the same side as the effort force. The effort force is going to be over this direction. So what we need to do is we need to calculate the ideal mechanical advantage, and we need to calculate the actual mechanical advantage. So the IMA and the AMA. Just like last time, a first class and second class lever has the exact same equations. The IMA is going to be the effort distance divided by the resistance distance, and the AMA is going to be the resistance force divided by the effort force. So we're going to need to find these two distances, and it should be pretty easy to do. We're going to take a ruler, and the effort distance, since the effort has been given at this handle all the way in the back here, we're going to have to measure this entire distance from the fulcrum horizontally all the way over to here. So we're going to have to move quite a bit in order to get the actual distance. So I'm going to measure that out, and it looks like I'm gonna run out of room. Fortunately, that 12 inches hits right at the end, so I'm going to do 12, and I'm going to add a little bit extra. That looks like an extra 2.5 inches that goes out. So 12 plus 2.5 is going to be 14.5 inches. So for the effort force, I'm going to write 14.5 inches. And for the resistance force, I'm going to be putting the load on, or sorry, the resistance distance. I'm going to put the load on right here. And we're going to measure out to the center of mass of the resistance. So you don't stop right here. You're going to measure all the way to the middle of the object. So we're going to get our measurement going. That's roughly about 5.5 inches out to the center of mass. So I'm going to put 5.5 inches. Now the inches are going to end up canceling out, so your answer is just going to be some kind of ratio between the two. Divide those two onto each other and you have the IMA. The AMA is going to be a little bit different. This wheelbarrow is really bulky, so whenever you lift it up, it actually takes a little bit of effort force in order to lift it up in the first place. So what we're going to have to do is we're going to have to subtract that out of the effort force. So I know that picking this thing up, I measured it earlier, it takes about 1 Newton of force just to pick this thing up. So that 1 Newton of force doesn't really need to be included inside the mechanical advantage calculation. If you put it in there, and if the bigger your lever gets, the more likely you are to get an error that your AMA ends up greater than your IMA. And physically that doesn't make a lot of sense. The ideal mechanical advantage should always be greater than the actual mechanical advantage. If it's not, you either messed up on the math or there's something about the construction that you're not thinking of at the time. So I know that the resistance force of this load is about 2.8 newtons. So I'm going to write the resistance force of about 2.8 newtons. And the effort force I'm going to take by putting the load onto the wheelbarrow, and I'm going to get a measurement of how much force this actually takes to pick up. And whoa, gotta balance it. It looks like about, I'm gonna say 3.2 newtons. I just have to barely pick it up because this thing is not very well balanced. About 3.2 newtons. So I'm going to write down 3.2 newtons for effort distance. The newtons are going to end up canceling out. You can use pounds, you can use anything that you want to. It doesn't matter as long as you keep the units the same on top and bottom. So this one's going to end up being 2.8 divided by 3.2. So subtracting that 1 Newton out, you can see that it might be a little bit different. Your AMA is going to be less than 1, which is definitely a lot less than what's going on there. But that might actually be due to the actual construction of it. Anyway, divide these two numbers onto each other and get your AMA calculation, and we'll be good to go.